Okay, so next we're going to talk about how you can find the radians. And I feel like this is usually the part where people get confused. Remember, radians are just another way to measure your angles. So the radians are going to start here at 0. Do you guys remember how many radians are 180 degrees? Pi. Yeah, 1 pi. Okay, so then this is going to be pi. And then a full time around the circle will be 2 pi. Okay, and then I also just want to remind you, if you wanted to convert your degrees into radians, do you remember what you can multiply by? Close. So you have to multiply, if you started with degrees, right? You would multiply by pi over 180 degrees, and then you would get your answer in radians. So you could do that for every single value, but that sounds like a lot of work, right? And really, if you had radians, you can multiply by 180 degrees over pi, and you would get your answer in degrees. Okay? But we're going to do this using logic, okay? So if we know that this is going to be 0 and this is going to be pi, would we agree that 90 degrees is halfway in between those? Mm-hmm. Okay, so half of pi is just going to be what? Pi over 2. Now, what is halfway between 90 and 0? 45. So what is half of pi over 2? Pi over 4. Okay, so look at this. This is half. Would we agree that 45 degrees is 1/4 of the whole top of the circle there? Okay, so then this is going to be pi over 4. And we are going to be able to fill everything just by knowing the first quadrant. Okay, so you will have a unit circle quiz where you're going to have to fill out the entire unit circle. Okay, and you are going to be able to do that very easily after today. So as long as you're following along with me, you should be good. All right, so now we have to figure out what radian values these are. You can think of it in terms of degrees. So this whole top half is 180 degrees, and this 30 degrees represents 30 over 180. If we did 30 degrees over 180 degrees, how many times does 3 go into 18? 6. So wouldn't this be 1/6? So can we agree that 30 degrees is 1/6 of the circle? Which would make this pi over 6. And then using a similar method, we would know that 60 degrees is what? Pi over 3. Okay, so we have already done quadrant 1. Okay, so now I'm going to show you how you can label the rest of the circle just from knowing this. Okay, so if you start at 0, we're going to look at the 45 degrees first. So if you go to 45 degrees, this is 1 pi over 4. If you go another 45 degrees, this would be 2 pi over 4. So this is 1 pi over 4. This is 2 pi over 4. What is 2 pi over 4 reduced to? 1 pi over 2. So then if I go 45 more degrees, this would be what? 3 pi over 4. Then I'm going to go another 45 degrees, which would be 4 pi over 4. And what does that reduce to? Pi. Okay, so then Bruno, the next one's going to be what? So I did 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. Nope. So listen to the pattern, right? So it'll be 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. Then my next one's going to be 5 pi over 4. Okay, so then this is going to be 5 pi over 4 here. And I'm going 45 degrees each time. Okay, now this would be 6 pi over 4, but what is 6 pi over 4 reduced to? 3 pi over 2. Good, so then this will be 3 pi over 2. But remember, we got this from 6 pi over 4, so then Ethan, what's my next one gonna be? Yeah. 7 pi over 4. Okay, now the rest of the circle you can fill in with pi over 6. So if this is 1 pi over 6, you guys see from here to here, this is 30 degrees. So I have to keep going 30 degrees. So if this is 1 pi over 6, you guys with me? Then you're going to go to 2 pi over 6. 2 over 6 is 1/3. Then you're going to have 3 pi over 6. 3 over 6 is 1/2. Then you're going to have 4 pi over 6. What goes into both 4 and 6? 2. So the fraction would be 2 pi over 3. Good. 2 pi over 3. Very good. Okay, so you can keep going with your pattern. So 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. This one would be 5 pi over 6. 6 pi over 6 reduces to 1. That's what we want. Okay, and then you have 7 pi over 6. 8 pi over 6. What's 8 over 6 going to reduce to? 4 pi over 3. Okay, so that was 8 pi over 6. This will be 9 pi over 6. That's already reduced. 10 pi over 6 is going to reduce to what? 5 pi over 3. Good. Okay, so that was 10 pi over 6. And then we have 11 pi over 6. Okay, another thing that you might notice about the radians is anyone that has a 6 over it is a reflection. So look at this. If I were to reflect this point over the axis, you guys see how this denominator is 6 as well? And then if I were to reflect this point, that's going to be over 6. This is going to be over 6. Same thing with the 4. 4, 4, 4, 4. 3, 3, 3, 3. Alright, so those are going to be your radians.